Okay, so this is going to be a reminder, because we did talk about this in geometry, about how to evaluate basic trig functions, sine, cosine, tangent, secant, cosecant, and cotangent, a little bit of a reminder about those, as well as talk about the periodicity, which is a fun word, of trig functions. Okay, the basic trig functions and their reciprocal identities. Remember, sine is defined as this is just in the unit circle, as the x-coordinate, the y-coordinate on the unit circle, right? It is also defined as the ratio of the opposite to the hypotenuse in a right triangle, if you'll remember that. Cosine is the x-coordinate, and that's also in a unit circle, and it is the adjacent side over the hypotenuse in a right triangle. Good? All these ratios only work in right triangles when you're talking about that. Now the tangent is the ratio of the sine over the cosine, aka the y over the x if you're talking about the unit circle. Or in the case of a right triangle, it is the opposite side over the adjacent side. Okay? Now remember, to go back to this, the sine is the opposite over the hypotenuse. In the unit circle, the hypotenuse is just 1, so it's really just the opposite side, right? That's how it ends up being just the y-coordinate. Okay, cosecant is defined as 1 over the sine, which means it is 1 over the y, which would mean it's the, hey look, it's the reciprocal. What's the reciprocal of this? It would be the hypotenuse over the opposite side. So these three things here are called the reciprocal identities. They're just the reciprocal of the original three trigonometric identities. So if we keep going, secant corresponds to 1 over cosine, which would be 1 over x, or hypotenuse over adjacent. Now, how to keep these sorted out. Sine does not have a cosecant does, which is how you can tell they match up, right? Cosine already has a which means it must match up to secant. Did I ever tell you that about 99% of people know that tangent and cotangent go together and they're reciprocal identities? Which means that when you're looking at that, it is the ratio of the cosine to the sine, aka the x over the y, aka the adjacent over the opposite. This is something we did address in geometry, right? So these are the definitions of the basic trig ratios and what are called the reciprocal identities. So if someone ever mentions that to you, they're talking about cosecant, secant, and cotangent. Periodicity of basic trig functions. Well, if you think about it carefully, the sine of any given angle, right? So here's some angle, let's call it theta, right? The sine in this is going to be this is x and y, the sine of that angle, the sine of theta, is going to be y, right? As a matter of fact, the cosine of that angle is going to be x. What happens if we were looking at a coterminal angle? In other words, what if we went around another 2 pi radians? We'd end up in the same spot, which means that if we're looking at the sine of theta but plus 2 pi, it would also equal the same thing. And the cosine of theta plus 2 pi would equal the same thing. Great, you say. Well, what this leads us to is that the sine of theta is equal to the sine of theta plus 2 pi n, where n is some integer. Meaning if we add 2 pi, or any multiple of 2 pi, maybe we add 2 pi twice, or if we subtract 2 pi, because n could be negative, right? Then we're still going to end up with the same value. So if you know that two angles differ by 2 pi radians, then that tells you that the sine and the cosine, at least, are going to be the same. Okay? We're going to talk about the periodicity of the other functions, but a little bit later. And this concludes our discussion of those basic trig ratios as well as the reciprocal identities for now.